So Assalamualaikum. So today for lab 3 we are going to do linear regression. So I've already saved this blend process under the BA lab session folder. The name is lab 3 house sale linear regression. So the first operator that I'm going to use is the read CSV operator, since we want to import a CSV file. So since there is no problem here, I'm not going to change or do anything. Finish, and then we are going to run. Okay, so this is the data that contained inside the file. So the next operator that I'm going to use is the store operator, since I want to save it locally and it is easier for me to retrieve. I'm still going to save it under the BA lab session folder. The name is house sale data. Okay, and then we're going to run. It's just the same data set. Okay, so the next operator that I'm going to use is the select attribute operator. Okay, why I choose this operator, because if you can see here, we are going to do linear regression, and I don't think we need the ID to do the regression, so I'm going to exclude it from this data set. So ID, apply, invert selection. You can see here there is an ID, and now after I run it, the ID has been removed. Okay, as I mentioned, we are going to do linear regression. So for linear regression, we need to change every single categorical data to numerical data. And if we look here, we have a polynomial, meaning that we have categorical data. Quite some of our attribute is polynomial, so we want to change all of this. If you can see here, the street, lot configuration, neighborhood, house style, to numerical data. So to do that, we are going to use the nominal to numerical operator, since we have quite a lot of attribute to change. And for the coding type, I'm going to use unique integers because I don't want to use dummy coding, because it will generate new attribute, and I don't want to do that because we have quite some of columns here. So as you can see, every data now has been changed to numerical data. Here you can see that just now it is polynomial, now it has changed to numerical. And yeah, so like just now the street, we have pave and gravel, so now pave has become 0 and gravel has become 1. Okay, so the next thing we are going to do, if you can look, our value, our data value range is quite varied, so we need to normalize our data. So I'm going to use the normalize operator. So since the data we want to adjust, we are going to use this normalize operator, since we want to adjust the values to bring all the values to quite the same range, so that we could get a higher quality of data. And the method, I'm just going to stick with Z transformation, because to avoid outlier issue, so that the outlier that has been transformed is no longer a massive outlier if it have an outlier. So I'm going to run it once again, and as you can see here, all of our data has been changed.
Alright, now let's continue with the linear regression. Just now, Ain has cleaned the data and changed the nominal to numerical. And I have stored it as lab3 clean house sale. So we drag it into the process and connect the output to the result. And we will run the process. and we will got exactly the same as I got just now, and we can see that there is no more categorical value. The statistic, all the type is data type is real. Alright, so now we go to the design, and next we will insert the set role operator. So we search for set role in the operator and drag it into the process. And as for the parameter, the attribute name, we choose sale price because sale price is the attribute that we want to predict, and target role as we change to label. Okay, then we run the process, and we will got that the sale price as the spatial attribute. Alright, then we go to design, and now we have to split our data set. So we choose split validation and drag into the process panel. So we will, for the validation, we will just let the parameters as default. For example, the split is relative, split ratio is 0.7, and sampling type as automatic. And then we will double click on the validation. And in the training process, we will drag the linear regression into the process. We will connect the training to training, model to model, example to threshold. So here in linear regression operator, we have to make sure that the feature selection as none, and others we will leave as default value. Alright, so next one on the testing. For testing, we have to apply model. So we drag the apply model and model into model, testing to unlabel. And for sim here, we leave it as default. And next, we will search for the performance operator and drag it into the testing panel. So we link label to label and performance to average. And after we have linked everything here in the training and testing, we go back to the main process and we connect the link model to result, training to result, and average to result, and we run the process. So here we got the performance vector, example set, and also the linear regression, and this is the example set just now. So for the linear regression, this is the coefficient that we got. As for the p-value, it is going to show either the variable is significant or not. So as you can see here, the p-value is 0.000. Same goes to the quality of material, the MS subclass. It also have 0.000 p-value, and it is important. The variable is significant, and the lot area, overall qual, overall condition, and the year built also important because it also have 0.000. And this one, the year remote add, it have 0.001. It is significant p-value because it is less than 0.05, so it is considered as important too. Okay, and then we look at the total BSM TSF, which the size of basement in square feet. Also we have here GR leaf area, and the last one we have the garage cars. So there are 1, 2, 3, 4, 5, and 10. We have 10 variable that is important for this data set. So here we can see that the y-intercept is -0. So based on the formula of linear regression, y equals to b0 plus b1x1, and this is the multiple linear regression. So when it is a multiple linear regression, the formula is The formula is basically going to be y equals to b naught plus b1x1 plus b2x2 plus b3x3 and until the 10 variable, as we have 10 significant variable in this dataset. So in order to search the sale price for this dataset, this formula is going to be used. Okay, so I think that's all from us. Thank you.